Hello, friends. This is a podcast to talk about Chapter 18 in the Regular Stats book. We are in Section 3 of the course, which is talking about probability. Key things that you should have already taken away when we did Chapter 17 is that any random phenomena, I don't know what's going to happen if I do that event one time, like flipping a coin or picking a person at random. But if I do it a large number of times, a certain pattern develops. All right, so the key thing to random is if I repeat it a large number of times, I get a result that's predictable. And the probability is the percentage of time that I would get a certain result if I repeated a random event a lot of times. The next thing we talked about was a probability model. And we said a probability was when you listed all the possible outcomes of an event and underneath wrote the probability of each event. And when we listed all the possible outcomes of an event, that is the sample space. So once again, sample space is the list of all possible outcomes, not how many there are, but the actual listing of what the outcomes are. And just a couple quick examples of a probability model. If I roll a die, then this is the sample space right here. This is the random variable x, can be any one of the faces that come up on the die. So 1, 2, 3, 4, 5, 6. So this is the sample space. And the P of x is how that's said. This is the probability of each one of these outcomes. In this case, because it's rolling a die, we say that these outcomes are equally likely. And we also had this notation. So in other words, the probability of getting a 3 is 1 over 6. The probability of getting an odd number is 3 over 6 because there are 6 total numbers and 3 of them are odd, and so on. We also looked at this example, which was a probability model right here, where the outcomes were not equally likely. And so this time, the sample space was a list of marital status, and below we had the probability that a woman picked at random from this population would have that marital status. And finally, we had the 4 big probability rules. Every probability for an outcome has to be between 0 and 1, 0 being there's no chance of it happen, 1 meaning it's 100% it's going to happen every time. All the possibilities, all the probabilities in a probability model have to add up to 1. The probability that an event doesn't happen is just 1 minus the probability. We call this the complement. And then if we have 2 events with no outcomes in common, we could add those together to find the probability of one or the other. And all that led us to this idea of a sampling distribution. And this paragraph probably sums it up as easily as it can be summed up. A sampling distribution just tells us what values some result, some random event can take, and how often those outcomes should occur. So in this case, the one we looked at in class, if we say the average of some result is 50%, something will happen 50%. So I expect a lot of results, sample results, to be around 50%. And the further above or the further below, the fewer results I expect. So I can get a percentage of how often any result would happen given that this is true. So how do we do these problems? Well, let's take a look. We're going to use our old z-score formula. And in every problem we do, there's going to be a p-hat, which is a statistic I get from the sample. There's going to be a p, which is the population parameter, but we're just going to say that's the fact that we're assuming. And then there's going to be a standard deviation. All these will be given. So pause the podcast and read this paragraph, and then I'll point out what you need. So let's look. It says, suppose that 62% of all adults think. So this is my fact. That's what's going to go right here of these airplanes. And they give me that the standard deviation is 0.015. That's what's going to go here. Then they ask me to find the probability that I get 65% or more, and that's the sample result that's going to go right here. So plug in those numbers and see what z-score you get, and we'll finish the problem in the second podcast.